Hello everyone, my name is Young Jung, Principal Solutions Architect at AWS. Welcome to the booth, and this is the demo for Smart Scaling, LG Plus Smart Scaling for 5G Core Network. And today, we want to demonstrate the scaling capability of the network functions running on AWS powered by AWS AI ML service. The key objective of this demo is to show how much we can improve this scaling capability with the AI ML service of AWS and with the automation tools of AWS service as well. If we use AWS to host network functions, and comparing to the traditional days of the data centers, in the traditional days, we had to equip a lot of hardwares and the kind of network capacity more than we need. But we want to really change this mindset to this industry. If we use AWS cloud for hosting those network functions, we don't have to prepare this overbooked resources. We can just use the right resources right in time, and then we can scale whenever we need more resource. That's the key benefit of the AWS services. And then we want to bring AI ML power to automate that process, predictably do this actually before the traffic surge comes in. That's the key objective of this demo.
Okay, so what we have here is data variables coming from UPF network function, and we are looking at peak user throughput and number of sessions that are established. So what we do is we look at the patterns of traffic, and we try to do three things. One is we look at forecast system, trying to predict how the traffic patterns and the sessions are going to be in the next 12 hours. And then we do the diagnostic system where we are trying to pick up of anomalies. Now what happens is with the forecast system, when we are predicting, there's a chance that the predictions are can be error prone. So as a contingency, we have a diagnostic system. Whenever there is a peak demand and something that we are not picking up by the forecast system, that's picked up by the diagnostic system as an anomaly. So in this particular demo, what we are doing is we are taking the real traffic data from the core, and we are streaming it to simulate the real-time systems, and using that to do forecast. And also we have developed an anomaly detection model on Amazon SageMaker, and the streaming data is hitting an endpoint that has been deployed, and we are getting real-time anomaly scores of the traffic.
Before moving on, I want to remark the partners we together worked with for this demo. LG Plus is our customer, and we worked with LG Plus customer to develop the algorithm for the scaling. And also we worked with the Samsung Electronics, who is providing cloud-native 5G core network for this demo.
Okay, so now let's look at the demo in action. Let's first look at the peak user data. What you see here is the line in blue is the actual traffic. The other lines that are in color, those are the predicted forecasts in three different confidence intervals, which is, we call it as P10, P50, and P90. What that means is we expect the traffic to be within these confidence interval. Now you will notice that we are simulating the data at the time of New Year because this has been the anomalous behavior that we know that there's a spike in traffic during the New Year's time when everyone is either messaging or making calls, and we know that there's a demand on the core network. And you'll see that in general, apart from the peak load time frame, we have the forecast system predicting the load. And during the times of New Year, when the demand is high, that is being picked up as an anomaly by the diagnostic system. And these two data are used to do the scaling, whether it is scale in or scale out, based on either it is an anomaly or a forecast that we are picking up on. Let's start with the demo here. What you see here is the CloudWatch dashboard. Let me first explain what's happening, all the functional components of this architecture. We are streaming data through Amazon Kinesis data streams, and then we pump that data through Amazon Data Firehose and send that to a Lambda function. That Lambda function is then calling the real-time SageMaker endpoints to get the inference on the anomaly score. We are doing that through the Lambda function. And let me also show you the forecast. This is how the forecast looks like with the 3 different confidence intervals. And we see that in general, the traffic pattern has been predicted, which is quite close to the original traffic, with the exception of the anomalies that are occurring at the New Year's timeframe.
I want to chime in to make a remark here because this is captured as an anomaly. That is because we only use 2 months of data. If we were able to accumulate the data set more than 2 years, then this will be no more anomaly anymore in the system. But right now, we are using 2 months of data. Comparing to the previous November data, certainly this is an anomaly. But if we had the last year's data and the before the other year's data, then it can be seasonal, kind of normal data. But at this demo, I just want to make sure this is captured as an anomaly because we are using some limited number of the data sets.
Okay, now let's look at what is happening under the hood inside of Amazon SageMaker. As you can see here, we are developing the anomaly detection model, one for number of sessions that are established, and also for the throughput, which is the RX total, which is the peak user data. We go through the process of SageMaker model building, and using these data sets, we look at the data analysis of how the original the original raw signal looks like, and we use that to run a forecast to run an anomaly detection model and deploy that to a SageMaker instance. So once the training is completed, the model is now deployed to an instance, and we have streaming data hitting an endpoint, getting the inference out. So that inference goes to Amazon S3, and we have the anomaly data coming in once every 5 minutes for the throughput information, and this is refreshed every 5 minutes.
And so anomaly data is uploaded to the S3 bucket, and then event bridge is pulling the data to the Lambda, another Lambda, to take a post-processing. In the post-processing process, it is looking the forecast number and the anomaly data score. And if anomaly score is higher than certain number, and then we make a decision to make a scaling in or scaling out. And that is implemented with the Lambda function here. And after this Lambda function is processing the scaling decision, then it is calling the API, another API, to reduce down the size of the worker node of the EKS or increase the size of the worker node of the EKS. That goes to the auto scaling group, and we can see that based on the network demand on the change of the network traffic, we can see that the size of the instance is being varying based on the network capacity of the requirement. So this outcome of the demo is shown in a dashboard. And if you can see the timeline, and then because we are running some intentional spike data, and based on the spike data, network capacity is getting increased. And then if there's a kind of normal usage of the network, then it goes down to the normal network capacity. And if there comes another spike, and then based on that spike, network capacity is getting increased automatically. Everything is done by automatically, nothing of the human intervention. That's the key of another aspect of this demo. Okay, as a conclusion, this demo demonstrated AI/ML powered scaling capability of the 5G network function when it is built on AWS with AWS services, AI/ML services, and Amazon EKS, and the AWS auto scaling group. All those building blocks are available to compose this whole entire service set. As the outcome of this service, we can see that we can achieve the operational efficiency. It will be better, and also as well the cost reduction as well. If we reserve all the instances more than the bandwidth we need, then comparing to that, if we use this architecture, then instance cost will be reduced down in our rough calculation. 30% of the reduction we can estimate. So likewise, it can be dependent on the network size and the scale. And if we do apply this demo to the other network functions, we can have more kind of efficiency of the cost and the operation. This demo wanted to deliver this key messaging. AI ML can bring the power to automate the process and also predict the KPIs to control the network capacity. Thank you for watching this video.